Very good morning to everyone. So for this fundamental of electrical engineering assignment, we are assigned to do the video assignment. So we are from group Chicken Dinner. So this is our member Li Yidong, Li Mingzhe, and Li Zhan Hui. Okay, so next, today we are going to state what is electric motor. So electric motor is the electric mechanical machine that converts the electric energy into mechanical energy. So for this electric motor, there is two main types. The first one is AC motor, another one is DC motor. Okay, so for this AC motor and DC motor, there are many types of them below the AC motor and DC motor. So all of these different types we are going to state and we are going to explain in the slide after this.
I'm Ming and I'm going to present about AC motor. AC motor is the motor that converts the alternating current into mechanical power by using an electromagnetic induction phenomenon. Okay, how AC works? How AC motor works? A ring of electromagnet are arranged outside the stator, producing a rotating magnetic field, and then the outer coils are energized by alternating current, thus producing a magnetic field that rotates around the outside of the motor. The constantly changing magnetic field also produces an electric current inside the rotor. The induced current then produces its own magnetic field and rotates as well. There are several types of AC motor that we are going to discuss today. First is linear motor, next is synchronous, and another one is induction motor. Linear motor. Linear motor will produce linear force and has unrolled rotor and stator. Induction motor uses electromagnetic induction to transform electric power into mechanical power. The working principle of induction motor: the electromagnetic coils energized in turn by the alternating current supply. When the coils are energized, the magnetic field will produce between them induces an electric current in the rotor. The electric current in the rotor then produces its own magnetic field that tries to oppose the magnetic field of the coil. The interaction between the two fields makes the rotor to turn. As the magnetic field alternates between the coil, it alternatively rotates around the rotor. The rotating magnetic field makes the rotor spin in the same direction at almost the same speed. There are two types of induction motor. One is single-phase induction motor, and another one is three-phase induction motor. Single-phase induction motor changes one-phase alternating current electric power into mechanical power by using an electromagnetic induction phenomenon, while in three-phase induction motor, it converts three-phase alternating current electric power into mechanical power. Synchronous motor. We provide three-phase supply to the three-phase stator winding and a direct current to the rotor winding. The three-phase stator winding carrying three-phase current, producing three-phase rotating magnetic flux. The rotor carrying DC supply also produces a constant flux. A repulsive force caused by the same polarity of the rotor and stator poles at a particular instant, which is north to north or south to south, and the very next instant it will be the north-south causing attractive force. It's unable to rotate in any direction due to that attractive or repulsive forces, and the rotor remains in standstill condition due to the inertia of the rotor. Thus, synchronous motor is not self-starting. Upon achieving synchronous speed, magnetic locking occurs and the synchronous motor continues to rotate even after the removal of external mechanical means. Synchronous motor. There are two types of synchronous motor, which is the reactance motor and hysteresis motor. Reactance motor is the motor whose starting process is similar to an induction motor and which runs like a synchronous motor. Hysteresis motor have the uniform air gap and have no any DC excitation system. The torque in the motor is produced by the hysteresis and the eddy current of the motor. Controlling of AC motors. There are devices designed to control the speed of the AC motors. One is AC controller and another one is variable frequency drive. AC controller. AC controller changes the power into adjustable frequency, and thus it makes the speed of the AC can be precisely controlled. Variable frequency drives. It varying the frequency and the voltage supplies, and thus the AC motor can be controlled. Application of AC motor. AC motor are primarily used in domestic applications due to their relatively low cost and durability. There are some examples of the tools using AC motor. First is power tool, a tool that is actuated by an additional power source and mechanism other than the solely manual lever used with hand tools. Pump is the device that moves fluids, liquids or gas, or sometimes slurries by mechanical action. Home appliances. Most of the home appliances uses AC, which accomplish some household functions such as cooking, cleaning, or food preservation. Conveyors. A common piece of mechanical handling equipment that move material from one location to another.
Hi, my name is Li Dong, and I'll be explaining to you about brushless DC motors. Brushless DC motors are basically machines that convert direct current into mechanical power. The working principle of brushless DC motors are where when a direct current motor works on the principle that when a current carrying conductor is placed in a magnetic field, it experiences a mechanical force. When a conductor, in this case an armature, is supplied with a current, it produces its own magnetic flux. The magnetic flux either adds or cancels out in the magnetic flux due to the field windings. The sum of these magnetic flux at one direction compared to the other exerts a force on the conductor, and thus it starts rotating. Some methods of controlling brushless DC motors are flux control method, where the magnetic flux due to the field windings is varied, which vary the speed of the motors. Next is armature control, where a variable resistor is placed in series with the armature and is used to control the voltage drop, and thus controlling the speed of the motor. Lastly is voltage control method, where voltage is controlled to control the speed of the DC motor. And the best method up to now is by voltage control, as the other methods, for example flux control method, affect commutation, whereas the armature control involves a huge power loss as there is a huge resistor in series. Now, these are some types of brushless DC motors. They are the self-excited and the separately excited types, and we'll be discussing this in the next slides. Separately excited motors are motors where the DC winding is excited by the separate DC source. So they are separated. The armature windings in the motor is energized and produces flux, which in turn causes it to turn. Now for self-excited motors, there are three types. There's the shunt motor, series motor, and compound wound motors. Shunt motors are motors in which the field is placed in parallel with the armature, and in series motors, the field winding is connected in series with the armature, and in compound, it is a mixture of both, where there is both in series and parallel. Now, for shunt motors, there are two subgroups of shunt motors. There is the long shunt and the short shunt. Long shunt motors are when the shunt field winding is in parallel with both the armature and the series field winding. And the short shunt motor is where the shunt field winding is only parallel to the armature and not the series field. Now, these are some applications of brushless DC motors. For the shunt motors, they are for driving constant speed lines and lathes, machining tools, and blowers and fans. They are characterized by approximately having constant speed and having very good adjustable speed, medium starting torque, which is approximately up to 1.5, whatever that is. Next is series motors. They are most commonly found in traction work and transit systems and trolleys and cars. They have variable speed and have good adjustable varying speed and a high starting torque. And lastly, there's cumulative compound motors, where you are found in intermediate high torque loads, elevators, planers, and rolling mills. As it is the same with the others, yes, variable speeds and adjustable varying speeds, and a very high starting torque.
Okay, so hi, I'm Zhan Hui. So I'm going to state about what is the difference between the AC motor and DC motor. Okay, next. Okay, so AC motor and DC motor, so we are differentiate them by their characteristic. So the first one, the most important thing is input current. So for AC motor, confirm it is powered by alternating current. For DC is direct current. So for the commutation process, yes, it is present in the DC motor, but it is absent in the AC motor. So after this is carbon brushes. So there is no carbon brushes in the AC motor, but most of the DC motor have the carbon brushes. Okay, so next is application. So for the AC motor, it's suitable for large and industrial applications, but DC motor, they are more suitable in small and domestic application. So starting, AC motor are not self-starting. It requires some external starting equipment, but DC motor, they are self-starting. So next thing is position of the armature. So for the DC motor, armature rotates while the magnetic field remains stationary. Okay, so for the AC motor, the armature is stationary and the magnetic field rotates. Okay, so for the motor life, so the motor life of the DC motor is short, but in the AC motor is long. Okay. So the last thing is maintenance cost. So the maintenance cost for the DC motor is expensive, but for the AC motor, so the cost to replace one new AC motor is cheaper than fixing the broken DC motor. Hence, the maintenance cost for the AC motor is way cheaper than the DC motor. Okay, so next. Okay, so this is our assignment. So we are from Group Chicken Dinner again. So thank you very much.